Thank you. Good morning, all, everybody. This is the continuation of the EPC series, and today we will be covering the measurement equipment and uncertainties related to that. We've got two very knowledgeable speakers, and I'll introduce them just before they present, and then we will deal with questions directly after each one presented. I'll be your host for today. I'm Carl Steyn. I'm a board member for SAWC. I'm also an assessor for SANAS on EPCs. May I request that you mute your speaker, mute yourself so that your noises around don't come through to everybody else and interrupt these presenters. The recording will be shared with those who attended. I presume Matlacho, can you confirm, please? Matlacho, you're on silent. You're on mute.
Okay. I beg your pardon?
Please just confirm that the recording will be shared with everybody.
I can't hear you properly.
Sorry, just confirm that the recording will be shared.
Yes, the recording will be shared. It will be shared to our members on the website.
Okay, good.
Yes, sir.
Thank you for that. Then without further ado, let me present the first speaker today. The first speaker is Dr. Senamela. And a short introduction for Dr. Senamela. He is a sustainability engineer and EPC inspector at Delta Carbon. He's also an energy manager in training with BTech in mechanical engineering. He's experienced in EPC inspections for the past 3 years. He's in energy management, energy efficiency, and mechanical engineering designs. He graduated top of his class and was a top #1 student for the National Diploma in Mechanical Engineering in 2016 to 18. Dr. Senamela, please proceed. We would like to hear from you.
All right. Thank you, Carol. Let me just try to share my screen first. Let's see. Just let me know if you can see it. All right.
Yes, it's visible. Thank you.
Do I miss this thing? How do I move? Okay. I'm trying
Perhaps you can just make it larger at full screen at the bottom there, that icon at the bottom.
Okay.
The icon, oh, there it is. Thanks.
Yes, yeah, there it is. So like, okay. Greetings, everyone. As Carol already mentioned my name is Dr. Senamela, and I'm the sustainability engineer at Delta Carbon. So as Delta Carbon, we are the catalyst in climate innovation, and we offer services from advisory, engineering, and verification. And we have a team that is committed to global sustainability objective and climate goals. And up to so far, we have a track record in MNV totals of 6,800 gigawatts hours of energy savings, and also 2.3 million tons of carbon dioxide in greenhouse emission reduction. And we also have assisted clients with energy efficiency tax incentives of about 6 million rand. Who's moving my slides? Because I'm not moving on my side. Whoever is moving my side, please stop, because it's distracting me. Okay. So now, jumping on to today's today's topic, we'll start by the use of measurement equipment in EPC assessment. And then from there, we'll discuss the importance of quality in measurements. And also I'll talk about the types of errors that you can encounter when you conduct the measurements. And also we'll jump back to the key parameters in EPC's assessment. Okay, sorry. And then from there, we look at the causes of uncertainties in EPC's assessment. And then I will finish my presentation with how to eliminate those uncertainties in the EPC assessment. So now, when you look at the measurement equipments, when we conduct the EPC assessment, we use the measurement equipments to measure energy consumption. We also use the measurement equipments to measure the flow areas and also the energy exclusions. So when we talk about the energy consumption, we're basically looking at the electricity consumption and also the fuel consumption. So the fuel consumption can either the fuel gas or solid gas or solid fuel, I mean. And then the other thing that when we talk about the energy consumption, we look at the solar power generation, if ever maybe a facilities has the solars. So now, when we look at the flow areas, we're going to look at the total area, the excluded areas, and vacant areas. And then when we look at the energy exclusion, we look at the energy that is being consumed in the storerooms, the energy in the parking lots, and also the energy in the outside of the building, for example, the outside lights. And now we'll jump to the quality in measurement. So now, when you look at the quality in measurement, it's basically affected by two factors. One is accuracy, the other one is precision. So when you look at the accuracy, basically is how close the result it is to the true value. And then the precision is basically how close the repeated measurements are close to each other. Then on the next slide, I'll look at more into example of accuracy versus precision. So now, let's say for an example, you're going for a shooting range course. Now you're going to, when you look at the picture there, is the representation of accuracy versus precision. So now the smaller dot on the picture on the top left represents your target. So now the black dots represent your results. So now when you look at the top left picture, you can see you're only hitting the target once. That means the accuracy is low. And also, as you can see, the results are scattered all over. That means that is the low precision. So the picture on the top right is a good representation of the high precision. As you can see, the results are more close to each other, but because of they are far from the target, that means that is the low accuracy. And the bottom left one, it represents the high accuracy, but low precision. As you can see, we are close to the target, but the precision is low because of the results are not close to each other. Now, the bottom right one, that's a ideal one, whereby the it is high accuracy and high precision because now they're hitting the target and the results are more close to each other. So now moving on to the types of errors that you can encounter when you do the measurements or when you evaluate the measurements. The first error is the stochastic errors or random errors. And these are the results of many unknowns and unpredictable sources. Then the second one is the systematic bias and deterministic error. This type of an error usually affects all the measurements or a section of the measurements. Then the last one is an outlier. So an outlier is a type of a systematic error in one of the measurements, and also is also referred as a planned or a spurious error. So now on the next slide, we're going to look at the examples of the errors as well. So now the picture on the left shows examples of systematic error and random errors. So if you look at the systematic error, let's say maybe you're required to do a measurement of a room, and now you're using a measuring tape. Let's say for an example, now your measuring tape is stretched. So if your measuring tape is stretched, that means your readings are going to be wrong. Actually, are going to be not accurate. So, but then even if it's not accurate, you're going to have precision. So that's one type of example of a systematic error. So now when you look at the random errors, one example is when maybe, let's say you're timing, you're doing a timing on a lap, maybe on a racetrack. Now your timing will depend on the reaction when you press the timer. So that is one example of a of a random error. So now looking at the picture on the right, that is an example of an outlier. So an outlier is just that one random measurement that is far from the other measurements. Then jumping to the key parameters in energy performance certificates assessment. So when we do the EPCs, we look at the following parameters. The first parameter is the energy consumption. So as I already explained, the energy consumption, we are looking at your electricity, the fuel, and the solar generation as well. And then now the second parameter is the net flow area. So the net flow area is affected by the total area, the vacant areas, and also the excluded areas. And the last one is the occupancy rate. So the occupancy rate is actually the rate at which users are occupying the building. So now, when you do the evaluation of the energy consumption, you normally request for the following. The first thing that you request is the electricity consumption data. And the other one is your solar power production, if maybe your facilities have the solars in place. And the other one is your fuel consumption data, if maybe you are having a diesel generator or a petrol generator. And the last one that you can request is the gas consumption. Maybe your facilities have like a gas furnace. So generally for the EPC, you will request for 12 months of data. But because of we are in the pandemic and things are not operating as usual, we normally request for 12 months of data. So you request for 12 months pre-COVID data and 12 months post-COVID data. And the reason for that is that, remember, the performance, the energy performance of the building on the EPC, it needs to be a representation of the performance of the building when under normal conditions. And because of we are in the pandemic, things are not operating normally. So it is key to have data before the COVID, so you can compare it to the data during COVID. So now when you evaluate the net flow areas, you normally request, the first thing that you request for is the scaled floor plans. This is supplied by the client. And the other thing that you request, the other thing that you do is the measurement sample. So the measurement sample can be done by the EPC inspectors, or even the client can also help with doing the measurement samples. And the other thing, you need to list the excluded areas on the floor plans, and also you list the vacant areas as well, because they affect the net flow area of the building. So now, when you do the evaluation of the occupancy rate, you generally look at the operating hours of the building, and you also request the biometric data from BMS for employees using the building. Now, the biometric data is going to give you an idea of how many people are actually using the building. And also, if maybe your building is being used as for functions, you normally request for the event schedule, because the event schedule is going to give you an idea of how the building is being used and when. Now, the pictures on the right, the top one is an example of the business hours for a building, and the bottom one is an example for event schedule for a racetrack. So now, moving on to the uncertainties. When you look at the consumption, what causes the uncertainties in energy consumption? So number one, one is this one. I usually get this one. I usually have challenges with this one because sometimes the municipalities, some of the months they use an estimated energy consumption, and the problem with with estimated energy consumption, it doesn't really represent the actual consumption of the buildings, so that causes uncertainties. The second one is when you have a broken or malfunctioning meter, electricity and gas. The problem with that one is that if your meter is broken, and let's say maybe it's broken for a certain period, maybe from February till June. So for those months, you'll have to do estimations for consumption, and that on its own is a problem because now you are estimating the consumption and causes uncertainties because you are introducing errors into your consumptions. Now, the other one is not having enough sub-metering in the building. So now, the problem with not having enough sub-metering in the building is that you might find that there are energy consuming equipment in the excluded area. So now, in order for you to get the consumption of those equipment in the excluded areas, you need to have a meter there so that you can note the actual one. So if you don't have that meter there, it's gonna cause uncertainties because now you're going to assume the power rating of the equipment and also the running hours of that equipment. So the other one that causes uncertainties is the incorrect running hours for the equipment. So by incorrect running hours for the equipment can also be like if you're not having sub-metering, as I mentioned before. Now you start by estimating how the equipment, the running hours of the equipment. So now that causes uncertainty because you will have errors in your energy consumption. And the last one is that not having details on the type of soil used in the facility. So what I mean by that is that maybe your facilities have a generator and your petrol generator. And when you request the information from the client just supplies you with liters of petrol from that the liters of the petrol that the generator uses. The problem with that is that now if you look at the petrol, we have different grades of petrol. We have the unleaded 93 and the 95, and those type of petrol, they have different energy capacities. So that causes uncertainties in the energy consumption. Now when you look at the net flow area valuation, what causes the uncertainties there is when maybe, let's say, you request data from a client and you request the floor plans, and now your floor plans, they don't have scaling or they have incorrect scaling. The problem with that is if you have incorrect scaling, that means if your floor area is going to be incorrect. So now you're going to get the incorrect energy consumption. Energy performance, yes. So now that causes uncertainties as well because remember the EPC needs to be at the you find that one of the offices is actually a storage area. And remember, a storage area for EPCs is regarded as an excluded area. So now, if you do the assessment on the net flow area, you're going to include the office, whereas that office is not really an office, is a storage area, and the storage area needs to be excluded on the net flow areas. And the other one is when you have unmarked excluded areas or unmarked vacant areas. The problem with that is that now, if you have areas that are vacant, but you didn't mark them or you don't know if they are vacant, you are going to include them when you do your evaluation on the net flow areas. And that causes uncertainty. And the other one is when you have outdated floor plans. Maybe the client supplies you with outdated floor plans, and then you do your area assessment before you do the site visit. And then when the day comes for the site visit, when you get there, you find that some of the offices that you see on the floor plans, they're not even there. It's actually an open floor office. So now that is a problem, because now your net flow area is going to be wrong, because now remember, when you do your areas, you are actually measuring from wall to wall. So if there are no walls now, you need to go back and redo the assessment again, and that is time consuming, and also it is going to cost the client more money, and also it's gonna delay the process of getting the EPC. And the last one is when you have inaccessible areas. So the problem with the inaccessible areas is that, let's say from the floor plans, you can see there are offices there, and then when you do the site visit, you find some of the areas are inaccessible. The problem with inaccessible area, number one, is you don't really know what's happening inside that area. You might find that that area is a big hall with no subdividing, or you might find that the area is subdivided, whereas on the floor plan it's not subdivided. So if you're having an inaccessible area, it raises uncertainties in the net flow area assessment. And the other one is when you the occupancy rate evaluation. What causes the uncertainties there is that, let's say maybe you don't have enough data on the business activities. For example, a client asks you to do an EPC on their building, and they tell you maybe this is the office building, but then you find that in some of the days they use that building as a church. So now, if you don't really know, if the client doesn't give you enough data on the business activities, then that's going to affect your occupancy rate, because now if you are having an office and a church, now that's multiple occupancy class type of a building. So you need to have enough data on the business activities as well, so that you try to eliminate the uncertainties in the occupancy rate. The other one is when you have incorrect vacancy data. I'll give an example, like, because now we are in COVID and things are not operating as usual. Let's say maybe the building before COVID, it had 100 occupants. Now during COVID, due to restriction, now they only allow 50 people. So now the client maybe doesn't give you that kind of a data. Maybe they give them, let's say maybe we only have 2 people using the building. That means the data is not correct, and that's gonna cause the uncertainty, and it's gonna affect your occupancy rate, because now if you are moving from 100 people to 2 people, that means you only have 2% occupancy rate. Whereas the actual one is you are moving from 100 to 50. That means your occupancy rate is 50%. So that causes uncertainties. And the other one is that causes uncertainties is the unorganized biometric data MS. Remember earlier on, I mentioned that we request the biometric data so that we get a feeling of how many people are using the building. So now, if you are having unorganized biometric data, let's say maybe raw data, you ask for biometric data, but then the client gives you raw data. The problem with raw data is that if a person accesses the building, let's say with the access card at the main entrance, it shows the name of the person. And then if you still have another access point inside the building, that name pops up again. And then from from the EPC inspector side, you don't really know if the person went inside the building and came out or what. So it is crucial that the client gives you the organized biometric data from BMS. And then the last one is when you have business hours not matching with the load profiles of the facility. So now, this one, let's say maybe the building is, according to the business hours, is operating Monday to Friday from 8 to 9. But then when you look at the load profile, it doesn't show any difference from Monday to Saturday to Sunday. So according to the load profile, it tells you that people are actually using the building. So people are actually consuming energy throughout the week. So that also affects your occupancy rate, because you're not really sure if the people are still using the building even on the Saturdays, whereas the business hours, they say on the Saturday there's no one in the building. So now I'm going to end my slide with the ways on how you can eliminate or avoid EPC unseating. So generally, the first one is that you should request for more data than it is required. As I already mentioned earlier, is that we are in the COVID pandemic. So it is wise when you do the EPC assessment to request data from before COVID and during COVID. The reason for that is that you want to compare the pre-COVID data with the current situation, and where the results should be the same, because of during COVID you have before COVID you have more occupancy, high occupancy rate in the building. That means, and also high energy consumption, because of the occupancy is directly attached to the energy consumption of the building. So now, if during the COVID data, because of you don't have people going into the building, that means your occupancy rate is low. That should also mean that your energy consumption should be low as well. So if you compare the two data and you find that two are not really balancing, that means something is wrong. Then you start to communicate with your client and try to get a feeling of what's happening in the building. So the other thing is you should assess the data before the site visit. By assessing the data before the site visit, I mean, like if you are, let's say the client gives you the floor plans, and you do the assessment on the floor plans, and then you find that some of the areas you're not really sure, because it doesn't show, maybe it shows that maybe there's no access to that area. So now when you go to the site visit, you have more questions, and then you have you know where to look at when you do the site visit. And the other thing is you need to do this sample measurement. As I mentioned before, when you do the sample measurement, you're actually confirming the scaling on the floor plans. And the other thing is you need to have like installed temporary meters for excluded loads. The reason for that is that to get the actual consumption on the excluded load, so that you can help you with your energy exclusions. And the other thing is that you can do is to request invoices, especially on the fuel purchases, because now on the fuel on the invoices of fuel purchases, you normally get the details on the type of fuel that is being used in the. And the other thing is you need to request the latest original copies of floor plans. If you don't have the latest original copies of floor plans, the problem is you might have the outdated floor plans, and then when you do your site visit, you find that some of the areas are subdivided. Now you need to go back and do the whole assessment again, area assessment again. So it's going to cost you more time and more money as a client. And yeah, I think that's the end of my presentation, and these are our contact details from Delta Carbon. And yeah, thank you. And I'd also like to say thank IPA for providing us with the training for EPCs, and also thank SAECC to provide us with the opportunity. And thank you guys for taking your time to listen to my presentation. Thank you. Is there any question?
Doctor, thank you very much for your presentation. Valuable thoughts that you've shared there, and certainly something to think about. But it's very clear from your presentation, there's huge amounts of uncertainties in EPCs, and it needs to be considered, and it needs to be included in reporting. So yeah, there's one question in the chat room, and it's Christopher. Perhaps you can, I'm not going to read it, perhaps you can just briefly explain what you've mentioned, and then we'll give Dr. opportunity to respond to that.
Christo, you muted your mic.
Oh, sorry, I asked to read the question to you. Sorry,
Yeah, please.
I lost focus a little bit there.
Okay.
So yeah, I understand the need for pre-COVID and post-COVID sort of reconciliation, but I mean, how do you go about that? You can't go back in time and put sub-measurement in. And certain areas, I mean, if we look at some basement parkings, the costs get a little bit extreme if you have to go do an energy audit, an accurate energy audit on a 2,000, 3,000 square meter underground parking, which is an excluded area, just to try get some pre-COVID data and or post-COVID data. I mean, putting sub-measurement in can help you for 3 months during or post-COVID, but if we're looking at pre-COVID data, you're going to have to do an energy audit and sort of work backwards according to some sort of formula. But I mean, that can skyrocketing, and yeah, I don't know if the market is really ready to be paying for that.
What I meant, okay, what I meant by getting the pre-COVID data. So I'm meaning if you are having a energy management system, a good energy management system in place, you should have some of the data, especially when you look at the energy consumptions. I don't necessarily mean the energy exclusion. So I'm just referring to the energy consumption of the whole building.
Thank
So
you,
I don't know if
Doctor.
I answered. I don't know if I answered.
Thank you, Doctor.
To an extent, it is answered. Yeah. I mean, we do, if we're accounting for the whole building pre-COVID, then we sort of, to an extent, have to account for excluded areas pre-COVID as well. Otherwise, your proportions are going to be out. But yeah, as Mr. Steyn said, there is a lot of uncertainty around this. So I think it's, if you can find a way to justifiably get your proportions proportionate, then I think that is, I guess that's our best bet at the moment.
Yes.
Thanks, Christopher. Any other questions for Doctor? Just check the. There are a lot of assumptions. Okay, Jared, you've posed a question. Perhaps you can read it yourself, please. Jared, I think you're on mute.
Okay, let me check. Can you guys hear me?
Yes, we can.
Yes, we can hear you now.
Wonderful. So I keep thinking back to a lot of the audits that I've done, and usually from the first SAC assessments until my final full energy audits, my accuracy goes from a case of like being 50 to 100% inaccurate through till being about 2% inaccurate. We're still dealing with the 50 to 100% mark with these energy audits. What are we going to do when we find out that there's a major inaccuracy that's sent a building from an A to a G or vice versa? Like, how do we is there going to be a process to retroactively fix that up?
Yeah, I'm not really sure. I'm not really sure if I understand your question, Jerry.
So we will discover as time goes by that there are mistakes. that will happen because we're not doing an in-depth audit.
Yes, yes.
How do we fix up the mistakes? If once we've issued a certificate that says somebody's an A when they're really a G, or it says somebody's a G when they're really an A, how do we fix that? How do we go back and fix that up?
Based on my experience, it usually never happens that you rate a client an A instead of an G. So those kind of errors, I don't think it's either
Not that
it's
you know
either-
about yet.
it's either you get the worst rating. So from the worst rating, you can only get better. So,
I think it's a valid question, perhaps an unfair question to Doctor specifically, because I could
Sorry.
ask Jared. I could
It's
ask
not
Jared
Dr.
exactly the
specifically.
same question. How are you going to deal with it, Jared?
I want to know that too, because I don't know how to deal with it yet. And I'm scared.
Remember the fact is that you're not supposed to issue a certificate that's wrong.
yeah, that's the you can't issue an EPC that is wrong. So
And uncertainty will make it wrong. So any certificate the rating might be correct, but the actual figure might be wrong. Krista, you've got your hand up.
Thank you, Carl. Thank you, Doctor. Jared, yeah, coming back and basically confirming what Carl just said is, if that is the case, there's a gross failure in your whole quality and management system that you have to follow in terms to make sure that everything's correct. However, let's keep that out of the way, and let's say for some fluke reason, something happened that you've messed up. Sorry, there. Let me just close the door quick.
While I see one individual says Jared will give the money back.
So yeah, let's leave out the whole thing that there is likely court cases, you might lose your accreditation and all that, because it does show such a large change does show a failure in quality management and so forth. So let's have a hypothetical case where you've missed 5 floors of basement parking for some reason. It's a different elevator. You were not unsure about it. A new guy that's operating or managing the building that took you through also forgot about the whole thing. So let's have that in play. That means that if you come across something like that, and what are the chances that you will get to that is in 5 years' time when the EPC is renewed. That's the most likely time. That means it's an update of the whole thing. That means you just need to reissue. If you reissue and 3 weeks down the line, someone phones you and says, listen, mate, there's 3 more basements and we missed that. That means you need to have an official withdrawal of that EPC that you issued, and you need to make an official resubmittance of the new EPC and clearly explain why, when, and how, and all that, with all the egg on your face and all the red faces that might be accompanied with that. Keep in mind that means each and every other EPC issued by you will then be reinvestigated, either by an internal source or an external source. And it's the same as someone doing blood tests or whatever SANA's accredited system is being used. If it's that big of a change between your original issued and your final issued one, that means there is a gross failure somewhere in the line, which brings everything that you did into a question. If it's a small change where the grade doesn't change, then of course it's not that significant an issue, but the same principle still applies. And therefore you need to make sure, this is what many guys do not understand, an EPC is not just get the bill, get an estimate of the floor area, and there you go. It's a large credibility issue that's on the line, your name that's on the line. The same as someone that goes to a blood center and all of a sudden you've got HIV with COVID and Kukumakrankas disease and you're coughing like me, And 2 weeks later, they came back and sorry, no, there was 5 cat hairs in the blood test as well. So, oops, sorry, you're wrong. Don't worry. Don't rack up all the credits and go on a skiing holiday and all that sort of stuff. That's the implication, and I think you understand that as well.
Thank you, Christo. I see your hand, Mogatli, but I also want to just respond. Jared, that's why we're having this workshop, so that we at least are aware of all the that we're going to experience. And you're correct. I've seen systems, metering systems that's very good metering systems that's totally wrong as well. So it happens, but that's why we're making you aware of that, so that you can make sure that you're not dealing with this in EPC, or rather that you deal with this in EPC and not ignore that. But yeah, Mogatli, you've got your hand up. Please respond.
Hello, can you hear me?
Yes, we
Yes,
can
I
hear you.
can.
So I just want you to share an experience that I had with a site where they didn't have any sub-metering or any meters of any sort. The only thing we had to go on was just the estimated for over 3 years. So for the past 3 years, the billing has been on estimates. So there's no way of getting any actuality. So what we had to do is practically now become a utility and energy consultant for them to try and at least get something that we can use, because they seem to be very urgent to try and at least understand something, and that was the only site they could offer us. So we had to go to council, ask them to come and do actual readings so that they can do a rebilling and adjustment, and then from there we can at least have some form of reading. And while that was happening in the background, we also added our own metering, not permanent, temporary metering. So hoping that at least we can get some form of behavioral operation. So the lucky part about this is that they are retail, so they operate similar, whether it's COVID or it's not COVID. It's just maybe a little bit decreased number of people, but not by much, just to, to not have a congested number of people inside the building. So at least you still, have normal operation in this instance. But again, there is no formula. Jared, even anyone in this webinar listening, there is no formula to this yet. The energy EPC is actually just a step into energy management, really. Once a person is there to do an EPC, there might be a need to add maybe even permanent meters, even for a year, and then come back and issue an EPC. There's that's going to be needed, and we are going to have to see it in that holisticness, that it's not just follow what the EPC regulation is and do that. We would have to follow it step by step, and see those other milestones and try to cover those gaps. I see I'm invoking some hands there. Let me give them a chance as well. Okay, thank you.
Thank you for that, Mogatli. Valuable input. I saw Christopher's hand first, and then Nevin's hand I see. Christopher, would you like to respond?
Yeah, it's not really a response, Marv. I would just sort of on the topic of permanent versus temporary metering. I just wanted to get a feel if everyone is, or if anyone has any comfort with the period of time that is justifiable to put in temporary metering and or permanent, and to extrapolate. Because I mean, if we're being honest with one another, the 8th of December 2022 is around the corner, and there's a high chance that some of these buildings are only going to do EPC inquiries mid 2022, and then they've got 6 months to put together 12 months of data because they've got no sub-measurement. So I mean, sure, it's all circumstantial, but it's also not right to log a main income for 15 days and then extrapolate 12 months out of that. I mean, it's irresponsible, actually, from a inspection body point of view, to sign off on something like that.
Thank you, Christopher, for that view. It is a valid point, but certainly the metering period can and could represent the actual operations as it would normally occur. And that's part of the job of the inspector. They need to make sure that the metering is credible enough to be used. And that's why we have this workshop to try and address some of these things. We will not address all of them. Nevin, please go ahead.
Hi, so hope you can hear me.
We can hear you.
Yeah, just a question. So I'm quite new to this EPC, but I think it's taking some interest, and it's definitely moving. So my question, EPC is focusing on areas bigger than 1,000 meters squared, and a building must be compliant to a certain specification, or is there a way to make sure in terms of 3 or 4 pointers, maybe Dr. Sanamela knows better, is there a regulation that we have to abide by for every building that's bigger than 1,000 meters squared, or that's still in development? Because I think the equations also is still being developed. So I'm assuming this is going into a phase of a fully developed course and energy course. So I was just wondering, in terms of the fundamentals, 3 or 4 points, and how do you ensure that a building is compliant? Is it, what kind of meters do you use? How intensive is there a checklist for making sure a building is energy compliant or certified? And or is
we will have opportunity. You can just put your hand down if you don't mind, please. The regulations is quite clear, and yes, you should read the regulations. You should make sure you understand the regulations, and certainly it is of value. Then the EPC training, it's extremely valuable. It covers the details of the regulations as well as the standard, and you need to know the standard, 1544, SANS 1544, and then XA 400 is related to that as well. So you need to understand and know the standards, almost off by heart, because the better you know the regulations and the standards, the better you'll be able to do the job. And there's ways and means to do with uncertainty as well. In measurement and verification, we try to do that to a much larger extent, but it is a much larger problem or challenge than in EPCs. But it's a similar challenge. It's not a small challenge. It is a serious challenge, and that's why we raise this as a concern. Let me introduce the next speaker. And the reason why I'm not allowing more questions now is one, for time, but also secondly, because I think he might be dealing with some of the questions that all sorts that we have. He's knowledgeable in this field. He's been involved with MMV for quite a long time, and he understands EPCs very well. Zadok Olinga is a board member at the SAWC. And he's a measurement and verification and energy efficiency specialist, and he assists corporate companies in obtaining cost improvements in their operations. He's worked on approvals of more than 2.5 billion rand in 12L and 12I tax allowances in a diverse range of customers. I'm not going to cover all of that, but there's quite a lot of types of projects that he's been involved with. He holds accreditations as a certified measurement and verification professional, and he's a certified energy manager as well. He's currently busy with his PhD, which focuses on microgrid renewable energy systems and optimizations around the implementation thereof. Zarok is also the president-elect for the SAWC, so from a certain point he will take over as the president. Zarok, over to you. I'd like to see what you present.
Thank you. Thanks, Carol, for that introduction. I don't think you left much out that I can speak on. Thank you guys for the opportunity to present to you guys today. I was contacted to present on this topic of uncertainty in EPC measurement. And I've sort of approached it from the point of view of uncertainty in general in measurement and verification, because EPC certification falls into the same category of M&V. So this morning, I'm going to be looking at uncertainty in a more theoretical, from a more theoretical perspective. I see that the previous presenter covered quite a bit of the practical aspects. So you'll see that there'll be quite a bit of repetition, but it will be sort of couched in the theory of uncertainty within M&V. Yeah, Carol's presented, given you an overview of what I do. I'm heavily involved in measurement and verification and energy consulting around energy efficiency predominantly, but I'm sort of willing to look at anything technical around the energy field. Okay, so why consider uncertainty? The previous speaker might have touched on it, but ultimately it is important that the results of measurement and verification, and in this case, the EPC certificate is presented with accuracy and quality. And the cumulative effect of presenting these things with accuracy and quality is you'll have confidence in the results, so confidence in the certificate being given to the building owner, to government, and I suppose for yourself as well. That's the key thing to why we need to look at uncertainty. Well, uncertainty exists in M&V because we don't have an exact knowledge of the value of the measure that we're measuring. So if we're measuring the floor area, the meter used to, the tape measure used to meter that floor area was calibrated at some point and manufactured over and over and over. So some error creeps into it. If you're measuring energy consumption, that meter will have a bit of error. So there'll be a bit of uncertainty as to the exact value. If you're taking samples, the fact that you're taking samples means there is an inherent error within that. So there is uncertainty in exactly what we're measuring. Doesn't mean, so just this point doesn't mean that what we're measuring is wrong. It's just that uncertainty is inherent in measurement. There are two types of uncertainty: quantifiable uncertainties that can be measured and unquantifiable uncertainties that can't be measured, such as where the meter has been placed, where the floor plans have been taken from. These were covered by the previous speaker. Wrong approximations and wrong estimates being taken. All these will feed into what we consider unquantifiable uncertainties. So sources of quantifiable uncertainty have been covered. We have measurement uncertainty. This arises from the accuracy of the sensors, the meters, data tracking errors, drift in calibration of the meter being used. In our case, the energy meters, the biometrics potentially could have issues with them. Then sampling uncertainties. So the previous speaker spoke of a need to take some samples of energy consumption, for example. How you carry out that sample, whether you cluster or whether you take an entire body of an entire population of objects that you're sampling, matters a lot. So sampling error will arise when only a portion of the population of the actual value is measured. And as I said, what portion of that actual value is measured? I'll touch on sampling uncertainty just now. Modeling uncertainty arises in the mathematical modeling due to an appropriate function form, inclusion of irrelevant variables or exclusion of relevant variables. My understanding of the EPC is we sort of have a set method of coming up with that formula, coming up with that value for the EPC certificate. So modeling uncertainty will not be too big an issue for EPCs. I've got Carol and Crystal here. Please feel free to correct me or jump in here, just to make sure we're getting across the right information. But my understanding of the EPC is that modeling uncertainty won't be that big a deal. So the two uncertainties are measurement and sampling uncertainty, and I'll dwell on those a bit. So with the sample size determination, to get the energy consumption of a building, you might need to take some samples of energy data. Now in South Africa, we have to take into account the seasonality effect on the energy consumption. So you'd have to consider how you're going to sample. Are you going to do a cluster sample where you sample different parts of the year? Are you going to sample the entire population of the year, and how you're going to combine those samples into your appropriate measures for energy? So what we have here is a sample size determination. The next few slides, the reference for them is the IPMVP 2012 version. I'm not sure whether they've released latest version, but if you go into the IPMVP and you check Appendix B deals with presents some. So you have your Z value, which is your confidence level. So an example that's typically followed in our MNV practice is 80-20, where you have 80 confidence and 20 precision. You take that 80, put it into the normal probability graph, and you get your Z value of 1.28, which is that. Your CV is the coefficient of variance of your samples. Typically, this is an approximation, so we tend to begin with a CV of 0.5 because we don't know what the actual variance in the samples is. And then E is your precision. So if it's 10%, E is 0.1. Then once you have that, you can use the initial sample size value N0, or if the initial sample size value is just too big and prohibitive. And in MNV, one of the things we have to take into account is the cost. If taking samples means more money, then the sample adjustment value formula may be used, where you take that initial sample size multiplied by the overall population size divided by the initial sample size plus the overall population size. That will reduce your initial sample size slightly. So you can find all this in Appendix B of the IPMVP. Now, related to the sample size is also the, sorry guys, just trying to move this thing away. There we go. Is also the standard error. So the standard error is a way of measuring the error within, is a way of representing and measuring the uncertainty. It's not the only one, but it's a commonly used one in MNV. So the standard error for sample sizes would be sigma divided by n, where sigma is the standard deviation of those samples that you've taken, and n is the sample size. So I think, just to reiterate, I'm not giving prescriptions on how to pick your samples. I'm saying that when you're picking your samples, it is necessary to follow a scientifically proven and given method of sample size determination. Within sample size determination, you can follow random sample size determination, where you pick samples randomly to avoid bias. So that is the most common approach followed. Or cluster sample size sampling, or cluster sampling with random sampling attached to it, where you cluster certain objects that you're sampling that are similar, and then you randomly select from them for sampling, and then afterwards you combine the entire clusters into a common sample. Again, Crystal and Carol, feel free to step in here. Then, yeah, so that's just the methods of sampling. You have random sampling and cluster sampling, which involves random sampling after you've clustered similar objects. So measurement error, as I said, comes from the imprecision in your measurements. The majority of meters, all the meters I've seen, come with specifications from the manufacturer, and they'll state the confidence with which the measurements will be given, and they'll state the precision with which they've been given. The previous speaker touched on precision really well. It's the most clear way I've seen it being given before, and I'm not gonna venture to explain confidence right now. I found it complicated to understand, to be honest with you. Again, we have a guideline by SANAS, which was compiled by some of the people here. It is TG50-2, compiled by Mr. Dr. Herman Carstens. It gives a concise definition on confidence and precision and how it relates to uncertainty. So please take a look at that, TG50.2. Yeah, I will add it into this slide when I submit them to, I'll add that reference to the slide when I submit it to Motlajo to distribute. But anyway, the standard error for metering is given as the meter relative precision given in the spec multiplied by the measured value divided by the t-value. T-value is taken from the t-table, which is based on confidence, on the confidence and precision level of the instrument again. And the assumption here is that this t-value is taken from an infinite or a multiple number of measurements that are done over and over and over. So you have that. So measurement errors arise from imprecision in your measurement. In terms of EPCs, we're looking at the measurement of the energy consumption, either whether you're taking it directly from a meter or whether you're taking it from the municipality meters. Typically, we tend to, and I speak under correction here, but we tend to take the municipality billing values and use those as given, usually the ESCOM meters, but often it's better to have a check meter, and that check meter will also have a standard error associated with it. If you really want to be exacting about your measurement of uncertainty, then you would want to look at the ESCOM meter installed, the type, the model, its specifications, and calculate that. But anyway, this is how to work out the standard error in measurement. Then the standard errors can be combined to give you an absolute measure of uncertainty for your EPC grade that you're giving. This is done with this formula. Again, this is from the IPMVP, where C1, C2, all the way to CP are independently determined components of uncertainty. So, you know, if you're determining your sampling uncertainty, your measurement uncertainty, and your modeling uncertainty, this is how to combine all the uncertainty into one measure of standard error. And so I've sort of rattled through the theory of how to measure uncertainty, what the types of uncertainties are. So how to manage uncertainty within EPCs. Took this from SANS 50010, which gives prescriptions on how to manage uncertainties for the measurement, for how to manage uncertainty in the measurement of savings or in energy efficiency. This part of it can also be applied to EPCs. So with EPCs, we're looking at our measurement boundary. So correctly identifying the building boundaries, so the meters squared, and correctly metering at the right points. One of the projects that I've looked at is for a massive utility owner, utility manager, and what the manager I was talking to, what the senior manager I was talking to, what he mentioned was, you have multiple buildings being fed from the same sort of substation, and sometimes multiple buildings are being metered from the same meter. So when you're going out to site, it is necessary to delineate which meter is metering what. And if you have a complication where different buildings are being metered from the same meter, then you'll have to segregate or disaggregate the energy consumption, which might mean installing a separate meter. Because often as well, when you go to a site that is a campus, for example, they might be getting one bill for that entire campus, but you need to give an EPC certificate per building. So you'll have to disaggregate or segregate the energy consumption that's being measured. So where you put your metering points is quite important. Including all energy sources. So on a site, and in South Africa, we'll have this with most facilities and large facilities. We will have the ESCOM electricity that's being fed into that facility, but we'll also have the backup generator. And if they have invested in solar energy, you'll have that as well. So for that building, you'll need to consider all the energy sources, the renewable source, the backup generator, and the ESCOM energy. Now, it's possible that some of the energy sources are not metered. So they might have installed solar panels and they haven't metered them. They might have diesel generators, but they haven't metered the energy from them being consumed by the building. Then we go back again to our modeling error, quantifying that energy based on mathematical physical models of energy consumption from that particular source. An example of the solar generated over a given day, days over that type of thing. How are you going to consider seasonality with solar power? So we come back to uncertainty in that, but you need to cover all the energy sources and to be careful in how you're quantifying the energy from those different sources. The frequency of data collection and measurement. So this feeds into what I just mentioned again, sampling, the competency of the M&V inspector. So experience is one of the best guides of confidence, of competency. But within that, you've also got training. So that's a point of these webinars. That's a point of different trainings that you can get online from Udemy, from, can't remember the other one, the other big one out there. Can't remember, but anyway. So continue training and getting training on these concepts on how to appropriately measure and verify to get your CMVP, to get your CEM to be responsible for the EPC measure, leads to a better perception of competency. Yeah. Then measurement equipment, ensuring that you're getting measurement from a calibrated meter. Within measurement and verification, we also have this concept of traceability. Traceability again is part of good quality management system. I'm not saying it's mandated by SANAS here. What I'm saying is having traceability of your calibration certificates, knowing where they came from, knowing where the data came from, knowing the accuracy of that data is important. Again, SANAS has a guideline. It's technical guideline TG51- I think it's TG51-2 or TG55-2. I'll have to just confirm that for you guys.
It's TG25.
TG25.
Yeah.
So there's TG25 for traceability in M&V. We've got TG50 for uncertainty in M&V that you can look at. I'll add those here as well. Let me just add those here while we speak. There we go. So yeah, measurement equipment, the key thing is the traceability of, because you have to report on these things and you need to maintain the data for a certain period of time. So you need to show where you got that data, the quality of the data source. Yeah, I think those are the two things. So typically what we use in M&V calibration certificates. Should you not have calibration certificates available, then TG25 gives some prescriptions on approaches you can follow to ensure traceability and to ensure certainty in the meter that you're using to obtain data that you're using in your EPCC certificate. Things such as maintenance records recommended. And then there are other tests that can be carried out to ensure the quality, the accuracy of that particular meter. That's the end of my presentation. I'm open to questions.
Thank you, Zadok. I knew you were going to cover a few things that was raised as questions, and certainly those that I had in mind, you've covered them for me anyway. Yeah, you mentioned it as slightly more theoretical, but I think it fits very well with the presentation that Dr. gave.
Yeah.
Thank you for all the documents loaded, Christo, and the references. I think there's only one document still that needs to be referenced, Zadok, and that's the document you created for Summers. Perhaps you can just find the details and add it into the chat room if you want, please. Because the TR25,
yeah, it's the one I want to refer to, but I just can't.
The TR25 refers to something else, so it's not.
Yeah, so it's TG50, the one created by Herman, and this one is, I think, TG55. But let me just confirm while we're here, because it's quite key that folks are able to look at it. I actually have a copy of it. What I'll do is I will send that copy as well to Motlajo. I presume I'm allowed to distribute it, right?
Yeah, you are.
Okay.
It's freely available from the website anyway.
Okay.
So you can load it in the chat as well if you like.
It's TG55-01. Yeah. So the two documents are TG55 and TR. So I'm just going to add another slide.
Sure.
I'm going to call it references.
Okay.
I'm going to put the references in there before I send it. Yeah.
While you're doing that, let me proceed. I don't see any questions. Jared had a remark. Would you like to expand on that remark, Jared?
I'm sorry, are you speaking to me or to Mark?
No, I'm speaking to Jared.
Okay.
Hi, let me see if this is working now. I just wanted to say thank you for the comments, Zadok, on the looking for other avenues for education. I think as a group, if anybody finds a great resource, it would be very beneficial and appreciated if such be shared, whether it's Udemy courses or new SAEC courses, just so that we can all be aware and upskill ourselves to keep the standard high.
Yeah, I think valuable information was shared in the chat room. The documents referenced by Zadok is also very valuable resources. And it's all valid to the environment we're working in, although it's referencing MND in particular. Yeah. But certainly it's of value in general as well. The reality is that uncertainty is something we live with. And I say live with because it's applicable to MND, EPC, and it's applicable to life as well. We're not sure what's going to happen in the next 10 minutes or tomorrow or whatever. So uncertainty is the reality of life, if you put it that way. But we do try to manage the uncertainties in our life. And there's no difference between managing uncertainty in life and managing uncertainty in a project and being at measurement verification or EPC. But we specifically referring to EPCs now. So the reality is that you do have to manage it. It's a requirement because remember your answer is incorrect. It's just people want to know how incorrect it is. And if you can guarantee the accuracy level, or rather the precision and accuracy, you provide confidence in the result. And that's really what you want to achieve. You want to provide confidence in the result. And that's why uncertainty becomes important and reporting on uncertainty becomes important. Any other questions, remarks for Zadok or for Doctor? I don't see anything in the chat room. Is there any hands?
Yeah, just a remark from my side. there's a misconception in society that when you say something is theoretical or academic, that it's not practical. That's not what it means. Academic means it's developed in an academic setting. Theoretical means there is physical theory, engineering, mathematical theory backing it. But that theory is taken from actual, from real life, from actual physical circumstances. So I did say I'm couching it in theory. Doesn't mean it's not couched in practice, because us who've been in MNV for years have been using these formulations, have been using these methodologies. So it is, that I've made my point. Yes, Linda, go on.
Yeah, Linda.
Good morning, Zadok, Carl, and everybody else. I thought I might just add, Zadok, thank you. That was an excellent presentation. I think the document that Carl also had in mind, which is not directly related, but it could be very useful to use, is actually TR 25-04.
Okay.
And what that document does, it gives criteria for performing calibration and intermediate checks on equipment used during the any process. So that automatically actually links up with uncertainty and all the other good things. So this document is available on the website, and I would encourage people to also look at that when you are looking at your equipment, your uncertainties, and your calibrations. Thanks, Carl and Zadok.
Thank you, Linda.
Linda, that's PR 25.
Yes, Zadok, PR25. The latest one is on the website. I've also added it to the chat room. You can just have a look there. The name is Criteria for Performing Calibration and Intermediate Checks on Equipment Used in Accredited Facilities. So it's a valuable resource there as well. Thank you for confirming, Linda. Linda, perhaps you can, is that an old end, Linda, or do you want to continue?
No, I'm just going to lower it now. Thanks.
Sure. Any other comments, questions, remarks? We've got some time left. Perhaps a question from my side, and Doctor, this is directed to you. How would you suggest we deal with outliers? If you do measurements on these huge outliers, how do you suggest we deal with that in EPC?
Normally, the outliers, most of the time, in my experience, you might find that it is a result of maybe the broken meters or malfunctioning measuring equipment. So if you are having that kind of a situation, and maybe you're having incorrect reading for 1 month, and is affecting your overall consumption greatly, I would suggest you do an average estimated, calculated estimation, so that you get at least you get most accurate consumption. So that's how I deal with it.
Thank you, Doctor. Then this is really directed to everybody and anyone, but we can start with a response from Zadok. And Zadok, I specifically pick on you because outside perspective might be valuable. Yeah. Remember, reporting uncertainty is important, we said.
Yeah.
If that is important, what do you think would be an acceptable uncertainty level for EPC? You referred to the 80-20%.
Yeah.
Typically for climate change, and we sort of use that reference in India as well. But
now
EPC,
I'm wishing Dr. Mark Rawlings or Herman.
It would be unfair. I know it's a slightly unfair question to you, but I thought you might have a think. And remember, it would be a very unfair question to Mark because he's not even in EPC.
as I said, the model being used in EPC, the mathematical formulation is quite straightforward. So you don't really have, error that we're getting from that particular one, or that we're quantifying from it. But with the measurement and the sampling, I would go as far as to say 80-20 is an appropriate level for confidence and precision to use in your sampling and in your measurement. If you want absolute confidence and precision, well, not absolute, but a higher level, then the other common one being used is 9-10. So often I will start my measurement and verification work looking at 9-10. Based on the amount of data that you have, like if we look at 12 for example, people will have 12 months of data, then you drop it to 80-20, which is not unfair. As far as the absolute measure, if you're looking at the standard error, I need to find the formula for converting the standard error to CVRMSE, the coefficient of variation of root mean square, which usually is the standard error divided by the mean, by the average. So you'd have to convert all your standard errors into RMSE values and then follow the same method I showed of combining uncertainties. And recommended in the IPMVP and what we use in MMV currently for 12L is a level of no more than 15% CVRMSE. So if your overall CVRMSE, your overall error is more than 15%, you should check the results out. A good level is between 0 and 10%. So between 0 and 10%, we can be fairly confident in the results being presented, you know, both for an EPC certificate or for energy savings being measured in for Section 12 or Section 12I. I think in the 80s, the IPMVP was developed in the US, and back then I think they used to be fine with going all the way to 20%. But if you look at TG50, SANS TG50, developed by Herman and with the help of the committee, I think they recommended between 0 and 15%. So anything more than 15% for CVRMSE is check it out. Anything of 10% or below is good. In terms of confidence and precision, 80-20 is acceptable. First question from Ben Baloy. And Ben
perhaps, Zara, I think Kirsten might have a response to what you just said, and then I'll see you and Ben, and then we'll deal with Ben's question. Kirsten.
Thank you, Carl. Thank you, Zadok. Thank you, Ben, for allowing me to jump in front of you. What Zadok just said is basically true. However, you don't just chuck out the results. Those values are used to guide you towards the best results that you can have. You can have results that have a CVRMSE of 30 or even 50 at some stage, but if that is the best that you have that represents the current situation optimally, then that is what you have to work with, and therefore you need to declare such. So those are guides and systems and results and calculations that you can use to guide you towards the best result that you can use. Now, at some stages, at certain areas, I wouldn't use a CVRMSE of 50. That is just a bunch of dots all over the place. But if you get a 22, 25 or something like that, and that is the best that you have, it basically shows stuff like operations are not really optimized. So sometimes the ovens are running without any cakes in them, and sometimes the ovens are full of cakes. It shows stuff like that.
Yeah.
So
I think you're speaking in the case of modeling, typically with regression modeling. As Crystal said, if you have operations that are not optimized, you're not going to get a correlation between your energy governing variables, factors, and your production, for example. So you're going to end up with bad CVRMSEs. But what I would say is what I've seen in a lot of reports, and the other practice that we do recommend for the 12L and 12I is to present the results with a range. So you're presenting them with a lower bound and an upper bound, and then for the sake of conservativeness, typically in MMV we pick up, and I would recommend the same thing for EPCs. That if someone is at a D with the possibility of being a D or a D, there we go. Specialism of the meter, but you might find that the sound is you might find that bound that you're presenting the results in still places them within the range recommended for a grade C, a grade D, or a grade B. Then you're fine. I'm not sure whether Barry is on this, and I know we have Linda and we have Carol, but I haven't yet seen what the actual report that has to be sent to Cincinnati looks like for EPCs, whether you must declare the amount of uncertainty and declare the EPC value with the kilowatt hour per square meter, declare it with a range, or must you just declare grade A to G?
Yeah.
Perhaps someone can enlighten me on that.
You've touched it on the Zadok, conservativeness is key. However, you can be over conservative. So if your results come back in and you are crossing 3 ranges of EPC, it's just too wide. And the EPC grade ranges are quite wide in their own. But if you are on the edge between 2 grades, I would then say, depend on your uncertainty level, then go the conservative route and rather choose the worse grade than choosing the better grade.
I think chances are you'll find that the range will still throw you within the grade because you say the grade's quite wide. So you're most likely to find that the range of reported results between your lower bound and your upper bound still throws you within the grade. So we don't have to worry too much about going outside the grades. I think it's the absolute number. If you're presenting 154 kilowatt hours per meter squared, it might be 155, 156, might be 152. For the purpose of the EPC grade, it is okay. So I'm not going on record as saying this, but strictly looking at confidence and precision for EPC measures, guys, don't nail me on the cross for this. Strictly looking at ranges for confidence and precision for the EPC, it's not too big a deal. What we would emphasize is to look at your measurements uncertainty, make sure that your meter is calibrated. And if it's not calibrated, make sure you investigate it for the error. So I got the thumbs up from Krista, so I'm on the right track there. So your meter, because the key measurement there is the meter. With the square meters, you can get that from the floor plans. So make sure your meter is calibrated. And if you don't have that, follow the traceability guideline on how else to ensure that the data you're taking from that meter is accurate. If you follow that, then you're going to find your CVR MSC is probably within a good range. It's not more than 20%. I still wouldn't take anything more than 20%, Crystal. and your standard error follows the CVR RMSC. They're related. Yeah, I think that's.
Thank you, Zadok. Ben, I'll give you the opportunity just now. I just wanted to respond on that. Just remember that, yes, uncertainty might not be such a major issue for EPC if you're still within the rating range. The challenge becomes an issue, uncertainty becomes an issue if you're very close to the edges of that range. Then you might, in actual fact, rate the building wrong.
Yeah.
If you do not look into uncertainty. Ben, thank you for waiting so long. Please pose your question or your comment or remark.
Hi everyone, can you hear me?
We can.
I wanted to ask about the kilowatt hour consumptions issues. So is it advisable to do a meter download on a meter? Let's say on this, or you have many estimates, and then you have the dates where they're doing their billing, the period which they're using. Is it advisable to do a meter download and take the actual meter readings from the meter download?
So I think I'll answer, then I'll give Dr. Sinamela to answer because he did cover quite the practical aspects of this. Direct data, I'd say, is always the best, but you have to be sure that the meter that you're using, the terminology I've seen being used is the check meter. You have to be sure that the check meter that you're using is of a high quality. Yeah, it's of a high quality. It's got a good deal of accuracy, that the precision is not off. You know, if you're reporting 10 kilowatts, it's not 15 kilowatts, it's 10 kilowatts or 11, you know, an acceptable level of precision. So, yeah, Krista can also step in on this. So I'd say you can take it from the meter, that's good, but the meter has to be accurate. But having said that, the bills is still fine if all the data is available, because you're looking at the annual energy consumption. So if all the data is available, you can take the ESCOM meters, and that I believe will be accepted by Seneti and the reviewers. But if you really want more accuracy, because some of these ESCOM meters might have not been calibrated in a long time, then taking it from your own building meter, because what I've seen is a lot of facility managers now are installing their own meters, which they use to follow up with ESCOM for bill reconciliation. So taking it from your own meters is probably advisable for better accuracy, as long as you know that the meter is of a good quality. It doesn't have drift, it doesn't have a systematic error, as Dr. Sinamela showed on that chart with precision. Yeah, over to you, Dr. Sinamela.
Thank you, Zadok. Doctor, comment from your side?
Yes, you just have to, I agree with what Zorak said. You just have to make sure that your meter is of high quality, and also make sure that your meter is calibrated. So if you have enough data from the municipality, you can use the municipality bills. But if you are missing some of the data and you have your own meter that is of high quality and also calibrated, you can use that data.
Thank you, Doctor. That's it. I think that question was addressed sufficiently. Thank you. Is there any other questions? Let me just have a look at the chat room. Okay, seems like there's no questions there. Any other responses, questions from the audience? Comments? Yeah, Jared says make sure the meter is installed properly.
Yes.
Yeah, extremely important. Guys, I cannot indicate how important this is. It
I think
doesn't
for
help
the
me.
EPC, it's a big deal.
Yeah, it is. It doesn't matter if you installed a calibrated meter wrongly, it's wrong.
Yeah.
It's going to read wrong. And you won't believe how many people makes a mistake. And remember, meter installations is a specialized field. It's not a simple exercise.
I'd advise, if you're going to site, to go with an experienced electrician who can read those schematics. Because when you get there and you find the way the meters have been set up, I was at a building 3 weeks ago, you'll find the same office or whatever is being measured from different locations. You'll find certain buildings are sharing meters. You want to see how the meters are, how the measurements are combined using the CTs. So just make sure that what you're looking at correlates to the building that you're looking at. So as Jared said, as Carol said, meter installation.
I can promise you, I've seen so many mistakes and problems with meter installations. It's not even, you know, CTs.
And also,
yeah, Doctor, continue.
And also, you just have to make sure that you're using the right type of a meter. Use like, don't stay water meter on the gas.
Yeah,
on the gas pipes.
No, that of course goes without saying. But certainly, remember, even the wiring sizes has an influence on the accuracy of the meter. If your CT is not working or it's the wrong CT or it's wrongly programmed for that CT or VT, then it's wrong. So it becomes a serious issue, and it's not a simple matter to deal with these issues. But thank you, Jared. Very important point, and not covered during this discussion, but most important for this exercise. Also remember, just to touch on the metering preference above billing. Yeah, it was mentioned bills are not always accurate enough in municipal, especially if it's municipal bills that gets estimated. But it's also true that actual meter readings will probably give you more information than only 12 months worth of bills.
They just simply quote.
Yeah, and therefore, remember 12 bills, if there's one missing, it's 12 missing. It's already quite a lot. And certainly your uncertainty increases with the lower amount of information you have. So yeah, Zarok, you wanted to respond?
Yeah, what I wanted to say was, not sure who mentioned it, whether it was Jared or you, Carol, but someone mentioned that the EPC is often the starting point for an energy management or energy improvement for that building. Because the idea is you've got a grade G, you want to come down to you want to come down to an E, or you've got an E, you want to come down to a D, C, whatever. So my own intuition is that it's good to be accurate, because then the building owner kind of knows where they are and where they can work to. If the EPC measure is inaccurate, then they might think they're in a very good position, and yet they're wasting a lot of energy. Or they might freak out and think they're in a very bad position, but usually someone might think they're in a good position, EPC wise, they're rated as C, but they might actually be a D. So accuracy is important for our clients so that they also know what they're working towards.
Thank you, Zarok. That's valuable information. I see Charles issued a statement on the chat room. For meter calibration, is the IB allowed to calibrate a reference meter source at an accredited lab and then calibrate and compare the meters on site to that reference? Yeah, you should actually, you must use a calibrated meter, so you must install, if you install your own meter, it should be calibrated when you use the readings from there. It's allowed. Just remember that the moment you carry around the meter, it becomes a portable meter, and calibration goes out much easier and quicker than with a permanently installed meter. Any other last remarks, comments before we close? It seems like this is going to a natural close. For those in the metering business, ensure you comply to SANS 474. Yes, very true. But usually, from experience, I've seen it's better to get metering specialists to do the metering stuff. They know what they're doing, and they make sure that you don't get. Remember, if you make a mistake, you might only find it out a month later or a year later. A metering specialist, he won't make a mistake. It's his job.
Sorry, guys. I think there's another meeting I need to jump on, and I need to rush to hospital. So if you could please excuse me.
No, Zarok, we're done. Thank you very much for both of you, Dr. and Zarok. Thank you for your presentations. Thank you for participating. A very important topic we dealt with today, and extremely valuable to everybody. We can probably have a topic, we can probably discuss this topic all day long and expand on each different point that was mentioned that will influence uncertainty, and go into much detail on each one of those uncertainty points and how to deal with them. And that's really what each one of us should be doing when we do EPC certificates, is to go into all these, define each and every uncertainty, and rate them and decide on how to deal with them. And if they're less important, you might want to ignore them. If they're most important, you might want to get very good measures in place to deal with them. So that's it from my side. I've given everybody an opportunity for last comments. But thank you very much for the presenters specifically. And lastly, thank you very much for those who attended. Without you, of course, why would we arrange for an event if there's no attendees? So it's most important that you guys are here as well. There's an EPC panel discussion at the conference next week. You might want to join us in that EPC discussion there. And there's also MOV presentations, which might give you some ideas on what to do. But certainly all of the presentations at the conference next week is of value to those in the energy field. So I would advise that you attend if you can. And then certainly, if I listen to some of the questions and remarks and what has been said, we all need training, we all need more exposure and knowledge. So, and there is certainly quite a number of courses that SAWEC arranges in conjunction with EPA. So do not hesitate to speak to the admin staff at the SAWEC to provide you with information in that regards. Thank you very much for everybody attending, and then till next time, remember 12th November, the last one of the series will be presented. I'm sure Mtlatsho will provide details via email before then. Thank you very much then, everybody. Keep well, be safe. Bye.
Okay. Mtlatsho, I see we are finishing.
Thank you, everyone. Okay.
Thank you, everybody.
Would you, hello, Linda.